and welcome to this latest talk in the Commonwealth Heritage Forum series on heritage at risk. Just so that everyone is aware, this talk is being recorded. We're delighted to have Helen Thomas here this evening to talk to us about a global assessment of climate change risk for the legibility of Commonwealth War Graves. If you have any questions, either during the talk or at the end, please put them in the chat, and Helen has kindly agreed to take questions at the end. The Commonwealth War Graves Commission is an organisation I know quite well, having done some consultancy work for them. And it's an amazing organisation, not only in terms of what it does memorialising the war dead from across the Commonwealth, but also for its huge heritage portfolio, which expands from the foothills of the Himalayas to the flat plains of northwest Europe, from the windswept Falkland Islands to the equatorial heat of countries like Kenya and Uganda, to name just a few of the 150 countries in which they have over 23,000 sites. So it's a really good organisation for the subject of this talk. And as I say, we're delighted to have Helen Thomas here. She is a collaborative doctoral researcher between the University College London Institute for Sustainable Heritage and Historic England, which is the English government body for heritage. Her doctoral research develops scalable methodologies for assessing climate change risk for the historic environment. She is currently the research assistant in heritage and environmental risk for the SASHA project, which is a joint enterprise by British, Norwegian, Italian and American universities. And she's also part of the research group Heritage, Environmental Risk and Data and Analytics at UCL, and an affiliate member of the UK Centre for Moisture in Buildings. So I can't think of a better person to talk to us today about this subject. Helen, over to you.
Thank you. Thank you, Rowena, for that introduction, and for Meg to the Commonwealth Heritage Forum for inviting me to speak as part of this really exciting series on heritage at risk. Today, I'm talking about Commonwealth war graves, hopefully all 1.5 million of them that are still intact. And we're thinking today about the global assessment of climate change risk for their legibility. This project came out of conversations that we were having during my research about how we assess climate change risk at a global scale and how we can think kind of beyond single site risk assessment to think more holistically about climate change risk for multiple aspects of the historic environment. Current approaches, when we think about climate change risk for heritage, can generally be divided into kind of two camps. There's kind of the single site risk assessment approaches that look at single individual sites, and then kind of landscape level risk assessment approaches. When you look at a single site and you think about climate change risk, you often have the kind of luxury of being able to talk to communities. Ooh, there it goes, to talk to communities, to think about the current condition of the site, to think about its past history, what it's made of, its material, etc. And so when you're doing a single site assessment, you can think more holistically about a climate change risk for a single building. When you scale that up to think about hundreds of sites, or in our case in England, the 400,000 sites that are on the National Heritage List, things get a little bit more complex. You don't always know what materials the building is made of. You don't always know the condition of the site, and you may not know if it has community involvement. And all of these things are going to have really drastic impacts on its overall climate change risk. So when we think about kind of landscape level climate change risk assessment, we often use GIS. So you can see here an example of a GIS system in Yemen that's looking at current sea level rise and past sea level rise to kind of look at changes. So using kind of global geospatial analysis, we can start to think about climate risk more holistically. But what we want to do, and what I'm trying to do today in this talk, is not just think about how climate change hazards are changing, so how things like sea level rise will change, how things like coastal erosion will change, heat waves, fires, etc., but what that actually means for the heritage site. So what does large-scale, global increasing temperatures mean for heritage, and more importantly, how we manage heritage in a climate changed era? So one kind of framework that we use quite a lot has been developed by the Intergovernmental Panel on Climate Change, or the IPCC. The IPCC is the kind of UN expert on climate science. You may have heard of their kind of big reports that come out every 5 years and kind of set the kind of benchmark for how we talk about climate change. So the IPCC looks at risk as not just formed of kind of climate change hazards, but also these other really key aspects. So thinking about, a site's vulnerability. Is it, in good condition? What is it made of? Also thinking of its exposure. So what is the significance? What's nearby? And then also thinking about response. So if we do nothing as a world, how will that increase risk? If we have a really active kind of climate change response, how will that maybe decrease risk? So today, what I want to think about is how we can just look at climate change hazards, but also bring in an idea of vulnerability by thinking about materials that are part of the Commonwealth War Grave and how that's going to change with their future legibility. So thinking about, future legibility for climate change, future legibility in a climate changed world for the Commonwealth War Graves, but also kind of exploring the methodologies that we use when we talk about kind of global climate change risk assessment. So those are kind of the two aims of what I'm hoping we can talk about today. So the Commonwealth War Grave Commission was started in 1917 in response to the scale of the fallen that happened in the First World War. It commemorates the almost 1.7 million men and women who lost their lives in the two world wars. And this commemoration can take form in the form of kind of individual gravestones that you can see pictured here, but also names inscribed in kind of a group or kind of war memorial. The idea is that they know the name and the body of the fallen, then that person will have kind of an individual memorial. I'm hoping that these graves aren't unfamiliar to you. They are spread out across every continent except Antarctica. And they're not just kind of in specific Commonwealth war graves, but they're also dotted around kind of local parish cemeteries. And so often if you're walking through a cemetery, you'll see a Commonwealth war grave, and they're often kind of easily recognizable because they all take the same kind of shape. They all have this very same form. And they're often made of Portland limestone, which is this very bright white material. When the Commonwealth War Grave Commission was thinking about how they're going to design the form of their gravestone, they wanted to make sure that all of the fallen were kind of commemorated equally, so that social or military rank was not included, that all the gravestones kind of had the same look, and so everyone was, equal in the fallen. And that's really important to the Commonwealth War Grave Commission, and also important to today's talk. Because when we talk about climate change risk, when we're talking about multiple countries, multiple different sites, hundreds and thousands of pieces of heritage, it gets really complicated when they're made of different materials and they have, different dates of construction and different histories. So what's nice about the Commonwealth War Grave for talking about global climate change risk is that they're primarily all made of Portland limestone and they all have the same form. So that kind of lessens the variability and lets us talk about climate change risk in a slightly different way. So Rudyard Kipling, when he kind of wrote a book, he was involved in the Commonwealth War Grave Commission in the early days. And in 1919, in the book, kind of The Graves of the Fallen, which was one of the kind of early guides to this, he said that it was realized above all that each cemetery and individual grave should be permanent as man's art could devise. So the idea of the Commonwealth War Grave is that these graves should permanently mark the fallen, and that they should be legible for future generations to understand kind of the cost of both world wars. So in climate change, with the kind of threat that climate change faces for the Commonwealth War Grave Commission means that these graves have to be maintained. They cannot be let to, kind of fall into disrepair. They cannot be let to, fall off the, fall into, issues that we have with climate change, in that the names need to be re-engraved and the graves need to be re-inscribed. So the Commonwealth War Grave Commission has a whole kind of series of works that they do to inspect their graves on a kind of rotating basis, to re-inscribe graves where the name is no longer legible, and to replace graves where needed. So it's really important that we think, how will climate change challenge this? Because it will have direct kind of impacts on how the Commonwealth War Grave Commission is able to maintain these memorials for the future. So Portland stone was primarily chosen as the material because it was of high quality, yet it was relatively easy to quarry, and it was also durable. And this is the kind of white limestone material that you see here. Some graves are made of different materials. There are some graves made of granite and slate, but primarily Portland limestone is the main material kind of used, and that's the main material we're going to be talking about today. One of the reasons that we're talking about Portland limestone is that it's been a series of various investigations over the past 20 years to think about how the surface of Portland limestone recedes over time. So this helps us answer this basic question, which is how will climate change impact future legibility for all the war graves made of Portland limestone? And this was kind of the central research question that informs this piece of research and this talk today. So as Rowena mentioned, the Commonwealth War Graves have, many sites across over 13,000 cemeteries, over 150 countries. So a really broad geographical remit. Lots of the cemeteries are located in France and Belgium, in the battlefields of the First World War, but there's others spread across the world. And so what we wanted to do is kind of echo the early days of the Commonwealth War Grave, where they designed every grave marker to equally commemorate each of the fallen. And we didn't want to just focus on France or Belgium, where there are lots of graves. We wanted to treat each cemetery the same. So with a global climate change analysis, we can look at all 13,000 cemeteries at once and kind of redress a lot of climate change research, which tends to focus on the global north. So the idea of this project was that we could take a very equitable approach to all the cemeteries, treat them all equally, and think about them the same in terms of future legibility. To calculate how legibility is going to change, we looked at kind of equations that talk about surface recession. Now, there's multiple ways multiple mechanisms of degradation for how tombstones change. For example, here we have a tombstone where little bits of moss have grown into the kind of crevices of the name, and in the bottom we have just weathering, so basically surface recession. So as various environmental factors hit the surface of the tombstone, the surface recedes and the names become less legible. So here I have my very simplistic model of a gravestone, and we add to this kind of climate factors such as precipitation and temperature, and also pollutants, and that kind of leads over time to the surface of the gravestone receding. So eventually the name may be less legible. To calculate this, we have this potentially scary equation. Now, I'm an archaeologist. This is not my background. And often when I look at things like this, my brain I start to kind of just glaze over. I promise it's the only equation I'm going to bring out today. But there's been numerous equations in the kind of past 20 years based on kind of site analysis to calculate the kind of basic rate of surface recession of limestone. So to take the material that the Commonwealth War Graves are made out of, and to think over the course of a year, on average, how much does it recede? So to this, we can add in pollutants, and these are kind of listed in the equation in red, and we can also add in environmental variables. So the pollutants are, sodium dioxide, PM10, and HNO3, and also the pH of water temperature. And then to this, we also think about relative humidity, precipitation, and temperature. So these are kind of the inputs into the equation, and this helps us model how Portland limestone will recede in the future. Because we're particularly interested today in just thinking about climate change, what we did in this piece of research was we standardized the pollutants. So we did kind of through the global values, we made them the same everywhere. And so we just looked at how the blue elements of the equation will change with global climate change projections. This piece of equation comes from Bartolini and his research group, and I'll also just flag that another research paper that came out a few months ago took a look at multiple equations for Portland limestone and found that there was some variability depending on which equation you use. So we've used this equation partially because of the background of how it was developed, but we're primarily going to be talking today in kind of comparative approach, so the percent of how things change as opposed to absolute numbers. So what we did is we took global climate change data for the worst case climate scenario. So when we think about our climate futures, kind of up to 2100, there are various climate futures depending on how we as a society respond. And so we looked at the worst case scenario and wanted to see kind of how bad is it going to get for these graves in the future. We established an historical baseline. So in climate change research, you tend to take 30 years of data. If you just look at 1 year of data, that's not really enough to establish kind of broad trends. We're not looking at weather here. We're thinking about kind of global climate change shifts. So we took a 30-year data, which is 1980 to 2010, and then we took 3 future periods up to 2100 to see how the kind of graves are going to change over time. Because we're looking at a global kind of resolution, and the data is pretty massive, we're looking at 50 by 50 kilometer weight kind of squares across the world. So quite big, quite a high global resolution. And then again, as I said earlier, we're looking at precipitation, temperature, and relative humidity. So this is the work that I did with this piece of work was also done with my colleagues here at UCL, and we talked a lot about how we would standardize pollutants, and we looked at multiple data sources. And I'm really indebted here with discussions that I had with my colleague Josep Grau-Bové, who we decided that these were kind of the quantities that we were going to use, so we could standardize these and therefore really focus on kind of what climate change is doing at the surface accession. So then we plotted temperature, precipitation, and relative humidity. We put this data and how it's going to change over 120 years, and also standardized pollutants into the equation that I showed before, and we kind of got out our results. And then we asked ourselves, okay, what does this mean for surface recession? So this is the annual average surface recession for our baseline period. So here we're just establishing where things, the level of surface recession in our baseline period from 1980 to 2009. So yellow areas are kind of areas that have low surface recession, and purpley and dark kind of black areas are places that have high surface recession. So this is not looking at climate change. It's just establishing the kind of basic level of surface recession across the globe. This maps on really well onto kind of what we call Köppen-Geiger classifications. So Köppen-Geiger classifications are based off 50 years of environmental data. We use them a lot in environmental science to kind of standardize and compare different areas. So basically you can see that areas with high surface recession tend to be areas that in the Köppen-Geiger classifications are equatorial and are humid. And the areas with low Köppen-Geiger, low surface recession, which is our kind of yellow areas in our map, tend to kind of classify onto the kind of mustardly colored areas in the Köppen-Geiger classifications, which are often really arid areas. So basically, if you have areas with quite high humidity, quite high precipitation, and quite high temperature, you're going to lead to higher rates of surface recession. So none of this is particularly groundbreaking. We see this with all sorts of degradation for stone and other types of material, that kind of rough environmental classifications can be used to think about areas that are going to be experience higher levels and lower levels. I'll just point out on the left that the range for surface recession is kind of 4 to 9.7 or 10, and it isn't millimeters a year. Thankfully, things aren't receding by 10 millimeters a year. That would be shocking. Though actually, it's micrometers, so it's very, very small. And so in a year, it's not noticeable to the human eye, but it's over multiple years that you start to see the change. So here we have our baseline, and areas such as the tropics and Indonesia and a lot of our islands and kind of middle latitude areas have much higher rates of surface recession as opposed to kind of the northern and southern areas. So then what we did is we took our future baseline and our far future baseline and kind of compared it. So basically, if we look at 1980 and we compare it to 2015 and 2044, our next kind of 30-year period, how do things change? Now, it's not all doom and gloom, which is quite exciting. Often climate change science, it's quite depressing how things look in the future. And actually with Portland, limestone and surface recession, we do see areas that are going to get better. So anything that's in purple is actually seeing a decreasing rate of recession, and anything that's in orange is seeing an increasing rate of recession. Because the world in many areas is getting hotter and drier, that's leading to surface recession rates decreasing, and this result has also been reported in both Mexico and Europe in the article below. So areas that are kind of seeing increasing rates, and those are orange, are primarily, there are a few inland areas, but it's actually primarily coastal and island areas that see an increasing rate. And here we're showing kind of percent change. So there are some areas that are getting kind of 10% better, and then some areas that are getting 7% kind of worse. So, broad scale, things that are getting better are kind of getting more better than things are getting worse, which is largely good. And if we just look at areas that are getting worse in a kind of a near future, then it's primarily coastal, and I'll show that in a second. If we jump ahead by another kind of couple tens of years, and we look at far future surface accession, so here we're looking at 2070 to 2099, so the kind of, looking quite far in the future, we're seeing kind of similar changes. So lots of places getting better, and then also places getting worse. But now the range is much bigger. So in some places there's a 30% reduction in kind of surface accession rates, and in some places there's a 16% increase. Now this this is just per year, so this is just the per year rate. We're not looking at kind of total surface accession yet. I'll bring that in a second. So basically from the baseline period, which is 1980 to 2010, when we look into kind of our mid-future and our far future periods up to the year 2100, we've kind of got a mixed message. So largely in Europe, where a lot of the cemeteries, mainland Europe, a lot of the cemeteries are located, we're actually seeing surface accession get better. Things are going to get better for a lot of those cemeteries. But in some cases, we're seeing it also increase. And if we look at the kind of areas that are just getting worse, it's really coastal areas. And we see this really often with climate change. Coastal and island areas have different microclimates than inland areas. And we often see with precipitation and temperature and humidity that these areas are going to be more impacted by climate change impacts. So here we're just showing areas that will see kind of 5 to 16% increase in the surface accession rate. Because we have the locations for each of the cemeteries, this lets us actually think about which cemeteries are going to get better and which cemeteries are going to get worse. So we can kind of make specific recommendations for which cemeteries should be kind of watched and which cemeteries are actually going to experiencing decreasing rates. So here we have the kind of top 10 cemeteries for the baseline period compared to the far future period. And those are kind of Jamaica, Italy, Ghana, and Singapore. A lot of these areas are seeing decreasing humidity and decreasing precipitation, while also seeing increasing temperature. So basically, they're becoming more arid, and that leads to a decreasing surface accession rates. Now, I'll just focus briefly on these ones in Singapore because this kind of adds to the slightly more complicated element about when you're talking about this kind of scale of data, and that not all of the graves that were cemeteries that we're talking about actually contained Portland limestone. So we've calculated surface accession to Portland limestone, but we can't say that all of them have them. So for one example, in Singapore, they've got a mix of materials. And on the right, the Kranji War Cemetery, that is a cemetery that's primarily Portland limestone. So this is going to apply. But for the 13,000 cemeteries, we don't know exactly all the materials. I mean, the Commonwealth War Graves Commission does, but that's not the data that we used. I'll also point out that just because sites are going to be, maybe experiencing a decreasing rate in surface accession doesn't mean they don't have other challenges that they have to deal with. So if you go to look at the Kranji War Cemetery, their big problem right now is that they're having wild boars coming into the cemetery. And the wild boars are coming in and kind of rooting around in the soil, and that's causing a whole host of issues. And obviously I can't account for, these kind of factors when we talk about surface accession, and the wild boars we're not able to model that quite yet. And so climate change in many ways is kind of a risk exacerbator, but there's still going to be other heritage management challenges for each of these cemeteries. And I'll also point out that these Singapore cemeteries are very close to Jurong Island, which is a very place of a place of high concentration in terms of kind of chemical production. So their level of pollutants are probably much higher than the level of pollutants that we stated because we wanted to standardize the approach. So with anything, we're showing that there's kind of 10 sites that are going to be experiencing decreasing rates, but every site is going to have its own story. So let's look at the 10 cemeteries that are most impacted by increasing surface accession rates. And these are found basically all in very coastal or island places. So we have in New Zealand, Australia, Kenya, South Africa, and then also on the coast of Brazil. And so these are very diverse. I mean, similarly with the decreasing cemeteries, we're not seeing them all located in one geographical area. We're not seeing them all kind of, in Italy or in France or, in Australia. They're very much spread out. So this is a global challenge that the Commonwealth War Grave has to respond to, and that those cemeteries that are going to be most impacted by climate change are not just in one region, but are actually very diverse in terms of their geographical spread. The thing that unites them is their location on coasts and islands, and that's something that we experience, across the world. Now, these are the cemeteries that are going to experience the most kind of increase from climate change, but it doesn't mean that these are the worst ones. These cemeteries kind of have a range of recession rates because they're in different types of kind of climates. So although they're seeing the biggest increase in terms of their surface recession rate, they're not necessarily, they may be going from like 6 to 7%, but there are some cemeteries that already have much higher levels of surface recession and then maybe see a slightly less kind of significant increase with climate change. And so when we look at the kind of top 10 cemeteries in terms of surface recession overall, whether it's climate change or not, and then we see a slight different highlights. So we've those suddenly we have cemeteries in Nigeria and Cameroon coming out as well. Again, a very big geographical spread when we look at the kind of types of cemeteries that are highlighted here. So what does this actually mean for legibility? We can talk about surface recession and we can talk about percent change and, in climate change and risk methodologies for heritage, we often leave it here because this is the bit that's kind of easier to talk about. We can put into our, our equation, we can test its sensitivity, we can use our kind of global climate change analysis, and we can do a big geospatial analysis. But actually kind of translating these numbers and these percents to what that means in a specific kind of gravestone it's much more difficult. This is kind of shades of grey. But we wanted to start doing that to kind of think about whether climate change is actually going to be causing a very significant issue for all of these cemeteries kind of across the Commonwealth War Graves portfolio. So to do that, we got to go into the field, which is very exciting for me. I spend a lot of time in an office, so every time I get to go outside, it's a good day. So we got to go into the field and we went to a bunch of cemeteries around London and we started looking at the various types of war graves and their conditions and looking at their kind of various levels of surface recession. Now, thanks to John Gedling, who works for the Commonwealth War Grave Commission, we were also able to look at their kind of internal guidance on legibility. So there's various elements on a war grave. There's the casualty name, the particulars, so the dates of birth and death, and the age, the personal inscription, and also the regimental badge and religious emblem. The Commonwealth War Grave Commission has different kind of standards for each of these. So it's most important that the casualty name is legible. If that's illegible, then the graves need to be reinscribed or replaced. But the other aspects of the grave can just be identifiable. So there's what the difference is between identifiable and legible is probably perhaps up to kind of, personal opinion, but it's much more important that we focus on how the names are receding as opposed to kind of other aspects of the grave. So with we were able to measure a bunch of the inscriptions in graves across London, and we were able to kind of standardize very roughly how deeply the names were inscribed. So basically the kind of like narrowest part was kind of 1.5 mil, and the deepest part was 3 mil on kind of graves that were in pretty good condition. So this is what the Commonwealth War Grave says about legibility. So legibility means that the grave is clear enough to read. The lettering or other engraved details may be weathered with some loss of definition. So weathering is fine. That's kind of natural on these kind of graves. It happens naturally over time, but they need to still be able to, you need to be able to make out the name. So here we have an example of a grave that's kind of on the edge of legibility. You can relatively kind of make out the name, but here we're pointing to kind of the last name Marshall, and we can see that the kind of M, A, and the R and the S are there, but it's much harder to see the H and the A and the L. So it's harder. I mean, we can probably make a pretty good guess of what the name looks like, but here we're kind of sitting on the edge of illegibility and legibility. And this is about at kind of 0.3 to 0.5 millimeters. So it's kind of, we said kind of around 0.4 millimeters. At that level, we're starting to really lose the depth compared to the other letters. So for example, the number above, which is much more legible. So this became our kind of guidance line. We wanted to kind of think, okay, with climate change scenarios, with the data we have, are we seeing a transition from kind of legible to illegible, and kind of is this crossing this kind of 0.5 millimeter mark? So we classified the graves into kind of 3 categories. So the ones that are in good condition, completely legible, still the inscriptions are quite deep. The ones that are in okay condition, and so there's a little bit of illegibility starting to happen, but that's, you can see that there's a bit of recession, but it's still, you can still read it. And the ones are already in bad condition. So this is our kind of example with the Marshall name here. Now, and this was based on us going out into the field and having kind of a look around, taking lots of pictures, and kind of classifying them to 3 groups. It's obviously a little bit, less scientific than the earlier parts, but this was us trying to feel out kind of how we could think about climate change and its impacts on legibility. So then we can think about, okay, in a climate changed future, if this is its current condition, in future, what kind of surface recession would mean it's illegible? So if it's in good condition, so it's got kind of 1.5 mil and 3 mil at the steepest part, if it has 1 millimeter of recession in the future, it's still going to be identifiable. You're still going to probably be able to read it. So graves that are in good condition, in the future, they're probably going to still be legible depending on the surface recession rate. If it's in okay condition now and it loses 0.5 millimeters, then you're entering into the illegible range. And if it's bad condition now and it loses kind of 0.3, then it's illegible. Then you're kind of basically having a blank face, and definitely the gravestone would need to be reinscribed. So when we think about the climate change future, it really depends, obviously, on how the grave is doing now. A lot of these graves have been, they've been built in the last 100 years, and some of them have already been reinscribed and replaced. But so they're in various levels of condition. They're not all at the same level, depending on where they are. So what we did is that we looked at the worst case scenario. So the worst case, so the highest level of recession, both now and in the future, is the memorial in Nigeria. And we calculated the surface recession for 1 year, 30 years, and 100 years. So if we're thinking about kind of 30 years, both in our baseline period and in the future rate, we're thinking about kind of 0.2 to 0.3 kind of total millimeters, which, it doesn't seem like very much. It isn't very much, but that could be the difference in a bad grave from going from kind of illegible to not illegible to not be able to read it. So that's kind of our 0.3 millimeters. So basically, both now and in the future, graves that are in bad condition now over the next 30 years, we're expecting that in these places they'll need to be reinscribed. And then we're saying that kind of in 100 years, the graves that, we're thinking kind of close to 1 millimeters of recession. So this is graves that are in kind of in okay condition are starting to become illegible, and that those are in good condition now are kind of, are starting to, not look so good in 100 years, which again is what we would expect. And you'll see here there's not a huge difference in this particular case between climate change scenarios and between the baseline period. So here climate change is not having a big impact. Now, this is for Nigeria, where there are graves, absolutely, but as I said, lots of the graves are located on the kind of France-Belgium border. So if we look at Vimy Ridge, which is where the kind of big Canadian memorial is, I'm Canadian, and so this is why I've chosen this one, and we're seeing a much lower recession rate both now and in the future, and this is actually an example of where it declines slightly for climate change. So here, even in 100 years, we're seeing kind of 0.6 millimeters of recession. So those are kind of in okay and bad condition, may need to be reinscribed. But those in good condition are probably going to be okay. So again, climate change is not making a huge impact here, and surface recession isn't looking kind of too bad. So what we wanted to do next is think about, okay, so we have surface recession rates for the baseline period, and we can run it for 120 years. So we can take our baseline rate from 1980 to 2009, and we can take that rate and we can calculate it for 120 years and say, okay, what's it going to look like in 2100? But we can also do that with kind of changing rates. So we can calculate 30 years based on the baseline period, and then we can calculate 30 years based on the next period, the kind of surface recession, then the next period, and then the next period. So we're counting the same kind of 100 years, but we're factoring in climate change. So in the first scenario, climate change is not happening. It's not real. We're doing 1980 to 2100, and we're not looking at the impacts of global warming. And in the second period, we are looking at the global impacts of global warming over 120 years. So we can calculate total recession for all the graves in the world without climate change, and we can calculate total recession for all the graves in the world with climate change. And we can then think about, okay, where is actually this going to pose a management challenge? And what we wanted to do is really ask ourselves a question: is climate change actually going to make any of the graves illegible by itself? So climate change, just the impacts of climate change, not just surface recession. Is it going to make any grave? Is it going to be the tipping point between legibility and illegibility? So those ones, the kind of worst case, if we just think about the worst case, those ones in bad condition, we've kind of established that at 0.3 millimeters of recession, we're going to start losing the ability to read the letters. So with the climate change future, are we going to see in any of these places an increase of 0.3 millimeters in surface recession because of climate change? And so what we can do is we can answer that by running these two scenarios, running our base rate scenario, running our climate change range scenario, and seeing if the difference is 0.3 between any kind of two locations. And the answer is, thankfully, no. The biggest change is 0.04, actually that's 0.04 millimeters. So nowhere near, basically. So we're thinking that, this kind of legibility level is 0.3, and actually the biggest change we're seeing for climate change, which is, in Nigeria, again, it's only 0.04. So climate change by itself is not going to make any of the war graves go from kind of legible to illegible. It's just going to exacerbate the kind of issues that are already there. So in Nigeria, without climate change, there's kind of 1 mil of recession over the next 120 years. With climate change, there's 1.04 millimeters. So it's a 4% increase due to climate change. So yes, these graves that are already, in Nigeria in the cemetery, they are going to see surface recession. They are going to go from, legible to illegible, but that's not, climate change is going to make that, 4% worse, but it's not going to be the tipping point. And for honestly, that's a really reassuring. Before, because we went into this, we really didn't know what the kind of climate change impacts were going to be on surface recession. And now we can find out that yes, there are places where it's going to increase, and yes, there's places that decrease, but that's not going to cause kind of a huge amount of reinscribing need that or replacement that needs to happen because of climate change. So it's going to happen because of general climate conditions, but global increasing temperatures is not going to be the kind of kicking point that these graves are going to face. So finally, then we can look at all the graves and we can assign kind of whether they're getting kind of on average worse or better, and we can see what percent over the years. So we can kind of model a climate change future for all of these graves in the worst case scenario, and we can model a kind of a non-climate change scenario for all of these, and we can look at the difference. So basically, again, all of those in purple are seeing kind of up to a 4% decrease in their surface recession because of climate change over the next 120 years. And then those in orange are seeing up to a 5% increase in the next 20 years because of climate change. So basically, those in mainland Europe, which is where a lot of the graves, as we looked earlier, kind of 11,000 of the cemeteries are located, they're seeing a decrease, up to 4% decrease in surface recession just due to climate change, and then other places are going to be seeing an increase. Now, actually, on the ground, this may be a little bit different because, as I've said, the pollutant levels could be different, the kind of materials could be different, but this on a very, very high level, what this lets us do is kind of say that climate changed induced surface recession is not going to be the main management challenge for the majority of Commonwealth War Grave cemeteries. For a few of them, it's going to exacerbate issues that they already have, absolutely, and we can very much say that that's going to be primarily coastal and island areas. But for many of them, the other issues that they're facing from climate change, whether that's to their greenery, to the vegetation, to kind of the overall look of the cemetery, that's going to be more pressing than the actual legibility of the gravestones themselves. So kind of a few simple conclusions. So in cemeteries where surface recession of Portland limestone, it's going to cause surface recession, especially those in poor condition. They may become illegible in the next 30 years, but climate change by itself is not going to cause inscriptions to become illegible. Coastal and island cemeteries will experience increased surface recession due to climate change, and that's going to exacerbate, current management challenges, whether that's, wild boars or whether that's kind of issues about access, etc. On a more methodological kind of perspective, damage functions like the ones that we've used before have been posited, and there's been a lot of increase in research in these in the last 20 years in cultural heritage, and they can be used to prioritize challenges for heritage management. Although, as we've emphasized, they're very much kind of work in progress, these equations, and they need to be kind of thought carefully about kind of how they are used and the kind of sensitivity of these equations. And then finally, kind of a global approach, using this kind of global approach ensures the equity of climate response. So every single cemetery is kind of, it can be treated the same. We have the same data for all the cemeteries in this piece of work. And so we can give each cemetery in the Commonwealth War Grave Commission and the same kind of surface recession rates, both now and in the future, how that they will change over time. And we're not just looking at kind of, basically the global north and specifically mainland Europe, where a lot of these cemeteries are located. So this kind of rectifies some of the imbalance that we've seen previously in climate change risk assessment research. And then finally, just some future directions for this work, because as I said, there's a lot that can be done, and a lot that can be done over the next couple of years with the Commonwealth War Grave Commission. So although we really wanted to just treat all the cemeteries the same, we didn't want to look at the kind of numbers of graves at each site. Some of these graves have, some of these cemeteries have 3 graves, and some of them have hundreds, hundreds or thousands of graves. So the amount, so yes, you may be seeing kind of a 4% increase in some cemeteries, but if that cemetery only has 2 graves, that may feel very, very different in terms of a management challenge than if that cemetery has 1,000 graves. We do have this data, but we just didn't bring this in for this presentation. So we are able to kind of weight our climate risk assessment based on the number of graves at each cemeteries, but we wanted right now to just look at each cemetery as kind of as if they were the same. We also didn't look at which war each grave is associated with. So wars, graves that are associated with World War One and World War Two, we do again have that data, and that means that they're going to be, they will have been built at different times. So some of them, will be over 100 years old, and some of them will be much younger. And therefore, the kind of impact of surface recession is very different. When we think about kind of climate change risk and heritage, it's rare that we have climate change data that's longer than the current life of the heritage. So if you think, for example, in the UK of Stonehenge, it's been around for, thousands of years, and we really only have climate change data up to 2100. So what's kind of interesting about talking about Commonwealth War Graves is that they've all been, they're all post 1917, and we actually have data of 120 years. So in many cases, we have climate data longer than its current lifespan. So by thinking about kind of each grave that the marker is associated with, we can kind of temper the analysis to be a little bit more specific. There's also the kind of issue of microclimate. So specifically, we wanted to look at a global approach, but that means that what we're talking about is very zoomed out. We're looking at kind of a very high level spatial resolution, which you need to do when you're looking at kind of global climate change data, but we're not counting for the local microclimates of each site. So this is an example from my local cemetery of graves that are sitting in a pool of water. So these graves are going to have different, management challenges, and those management challenges are probably going to exacerbate the surface recession rate. So what we've done is establish kind of base surface recession and climate change impacts on that. But what we can now do is look on a more kind of a microclimate analysis. And in the UK, we've started to do this with more specific climate change data on a 1 by 1 kilometer spatial resolution to see how that kind of changes on a much kind of smaller spatial scale. And then finally, the perception of legibility. We know that, in different light conditions, legibility is going to look very different. We happen to we went to these graves on various days, but this is kind of based on legibility, kind of very good legibility and good lighting. So we know kind of on gloomier days with waking light versus direct light with shadow, legibility is going to be very different. Different people are going to have different ideas of legibility. If English is not your first language, perhaps it will be harder to make those kind of mental leaps with terms of names as kind of letters degrade. And so the whole kind of legibility is it is the perception of legibility, and it's not as exact as the surface recession equation will kind of have us believe. And so that's definitely an area that we'd like to explore. I'm going to stop here as it's 6:45, but I'm happy to take any questions, and Romina will hopefully see if there's any that's been in the chat. So I'm just going to stop sharing my screen, and now I can see you all.
Helen, thank you so much. That was such an interesting talk. I feel like I've learned a lot in a very short space of time, so thank you for that. There currently aren't any questions in the chat. If anybody has any questions, do feel free to ask whilst people are coming up with some questions. I was wondering, you mentioned briefly about community having an impact on sort of the risk of climate change. I wondered if you could expand on the difference that sort of community engagement might make in this line of work.
Yeah, absolutely. I mean, so this is one of the kind of things we struggle with when we do kind of global climate change assessment, is that it's really hard to take in kind of community factors into it. So when we look at single sites, we can think about, do they have, local communities, and are that engaged? And that's absolutely going to mitigate the impacts of climate change. So what we wanted to do on a kind of a first basis with be able to kind of give each cemetery the kind of same amount of data. So whether a cemetery is actively maintained or not maintained, they would kind of be able to have the same be able to get the same kind of response based on the data we gave them. But absolutely on a local level, the community is incredibly important. The Commonwealth War Commission has an incredible network of volunteers who are very dedicated to going and cleaning the memorials and inspecting them. They actually have a whole kind of cycle of inspection that's often done by their volunteers and then kind of reports back to a local head. At least that's how it kind of works in the UK. And that would be, a really exciting avenue of research because, as I said, the impacts really depend on the condition of the gravestone. So if it's in bad condition now, then 30 years is going to be a problem. Where if it's in good condition, then 30 years kind of isn't going to be a problem. And so there is kind of up-to-date condition monitoring on each gravestone. That's what informs whether they re-inscribe or replace tombstones. And it would be, and that a lot of that is done by volunteering. And so the idea would be, would be incredible if we were able to kind of incorporate some of that data, and if it's kind of formalized in the way it's recorded. I think a lot of that is done by local chapter. It's not necessarily kind of scaled up into kind of a global data set. But absolutely, crowdsourcing is one of the kind of heritage citizen science approaches, is one of the kind of more exciting things that we can do with climate change risk assessment, because it's going to be able to provide that kind of current condition assessment that it's just really hard to do on a global scale.
Thank you. Does anybody have any other questions for Helen? Either raise your hand or put them in the chat. That would be great. I was also wondering, Helen, what the potential implications are for other historic buildings around the Commonwealth in terms of, for example, you've been looking at stone. So do you think that this sort of might help understand the potential climate risks for other stone buildings as opposed to headstones, or
Yeah,
is
absolutely.
that
I
too
mean,
big a leap?
yeah, it's on the first level, it would apply to anything that's inscribed. So any monument that's made of Portland limestone, and lots of military commemorative monuments are made of Portland limestone across the Commonwealth. And then anything that is just Portland limestone generally, so even decorative elements. So a lot of the things on the National Heritage List, I mean, like we looked at Portland limestone and that material usage on the National Heritage List here in England, and we're able to kind of think about how decorative elements might change over time with the kind of increasing surface accession or decreasing surface accession in the UK. So we have kind of done that next piece of analysis for the kind of UK commemorative memorials, but because largely in the UK, apart from the Northwest Scotland and the Scottish Isles, which do see quite an increased rate, partly because they're islands and coastals, we're seeing a decreasing rate. So we've actually been able to look at kind of Scottish memorials and say, look, that lots of these places you are seeing an increase. And absolutely, if you're made of Portland limestone and you've got anything inscribed or decorated, then it's the same kind of conclusions can be made. I'd also say that these kind of damage functions that have been created are not just limited to Portland limestone. We've just looked at that because that's what we were interested with Commonwealth War Graves, but they've also been created for kind of sandstone, glass. There's ones for paper. There's ones for other materials. So absolutely, depending on where you are in the Commonwealth, you may have a different type of stone more commonly used, and so there are kind of an increasing amount of research on these kind of damage response functions.
Thank you. We've got a question from the audience. Would you like to turn on your audio and ask your question, please?
Yeah. Hi. Hi, Helen. Thank you for such an. Sorry, I can't switch on my video right now. But thank you for such an informative and especially the methodological part of it. It's very incredible and very structured. My question is about, you're dealing with such a large quantum of sites and uh, these things. Can you share any experiences about uh, the challenges related to the data management, and also if you're taking any precautions about to keep that data dynamic, to keep on building in future as well, because I assume that because you're making all these future predictions, you will have to keep adding to that data. And also there are so many other, like, stakeholders in terms of the site managers, these people are involved. So yeah, the data related challenges and its shareability and keeping it dynamic. So I was curious about that.
Yeah, thank you for your question. It's my computer crashed many times in the analysis of this in this program. So the data that sits behind this is massive. From the cemetery's perspective, the Commonwealth War Grave maintains an open access database, which you can go to the website of all the cemetery locations, and so that's something that they keep up to date, and that's so they've been able to provide to me the kind of the geospatial locations, but anybody could look at that. On the kind of climate change side, the data is really big, and we're quite lucky at UCL in that we have kind of access to basically high performance computing, which helps us. So this was all kind of done through a programming language R, and the kind of code is relatively simple, but that kind of helps us do the data. It's not insignificant to repeat it as the data changes. Like you can do it, but I think one of the limitations of this kind of analysis is that you kind of do it once, and then if you don't have the resourcing power, you don't maybe do it again as climate change data shifts. So it's a really good question. I'd say that one thing that we were kind of hoping to do is that this has looked at kind of the worst case climate scenario, but there's multiple others, kind of four other main scenarios for climate change, and so we didn't run any of the other ones, and we would like to. Kind of in the future if we have the time. So in many ways the data isn't that dynamic because we've kind of like the climate change data kind of gets reevaluated depending on the source we use, gets redone kind of every 20 years. And so it's relatively static in terms of its data, but the cemetery data does get updated really regularly by the Commonwealth War Graves Commission, and so that's something they're quite lucky that they're quite open with their geospatial data set.
That's okay, great. Thanks for the information. Can I ask one more question?
Yeah.
Um, yeah. So I mentioned in your maps, there were also, I think, 2 or 3 locations in India. Can you mention which are those locations exactly?
Oh, I couldn't off the top of my head. I couldn't. I'd have to look it up at the because I couldn't tell you which slides, which cemetery names they are with 13,000 cemeteries. But the slides will be shared afterwards, so you can have a look at
Okay.
where the locations are. And please feel free to get in touch. I can tell you which ones in India are kind of
Yeah, sure. So I'm a conservation architect by training, and my current research is about some of the coastal forts in India, and I'm
Mm.
looking at the stone deterioration patterns and also the use of digital techniques to understand this. So your study is really relevant for my research. I'll definitely reach out.
Yes, please
Thanks
do, and I'm
for
happy to
today's
share the kind of
presentation.
the data. I mean, the digital, this is something we also talked about with kind of the digital mapping of stone deterioration and where things are likely to be, how legibility changes across the surface of the stone. If there's some kind of modeling you can do, taking in a bunch of inputs and seeing kind of what the patterns are of legibility in a certain kind of graveyard. For example, the orientation of whether a grave faces north, east, southwest is going to have a very big impact, can have a very big impact depending on the prevailing wind, etc. And these are the kind of microclimate aspects that are really important if you work on specific sites, but just very hard to factor into this kind of level of analysis.
Yeah, true. Thanks. Thanks once again.
Thank you very much for your questions. Does anybody else have anything that they would like to ask or contribute? We've got a couple of minutes before we're due to finish, but we can finish early if there are no more questions from anybody. Well, thank you very much, Helen, on behalf of all those in the audience and on behalf of the Commonwealth Heritage Forum. We're very, very grateful that you've given up your time just before you fly back to Canada to talk to us about this subject. It's really interesting. I think we've all learned a lot. It's given us a lot of insight into the work that's being done to understand the risk of climate change on historic buildings, which I know from my work in the UK is a major issue that comes up time and again at the moment. So thank you very much indeed, and I hope you have a good break back in Canada.
Thank you. Thank you to everyone. Thank you for the invitation.